Greetings and welcome to the Mobile IT Community of Interest monthly meeting. Thank you for joining us today. Before we get started, I'd like to review how to use the GoToWebinar system in order to optimize your experience today. You're all on default mute settings due to lots of participants on the call. You are encouraged to please forward any questions that come up using the questions tab for the end. In these meetings, the mobile IT community, questions will be read after the presentation and we'll identify who is asking the question in order to foster further participation and interaction between attendees. If you want to remain anonymous, just say so in the question. During the presentation, we're going to have a live polling session, which you'll be able to answer from the choices provided. Use the orange arrow button to minimize the control panel, and you can also move around the webinar interface on your screen. Thank you, and we will now start the presentation. I'm Stuart Young. I represent Fiatech in Europe and the Middle East. On behalf of all of us at Fiatech, I'd like to thank you for joining us today for the Mobile IT Community of Interest monthly meeting. Today's presenter is Marvin Johnson from Bechtel. Marvin will present on the results of a pilot study on the use of augmented reality technologies in civil construction. Before we get to the presentation, I'd like to take a minute or two to introduce Fiatech-COMIT and this community of interest to those who are not members of Fiatech or COMIT and those who are new participants to this community. Fiatech is a member-based organisation with an objective of accelerating the deployment of technology in the capital projects world. We have nearly 100 member organisation partners, including academia and subject matter experts, and also companies of other denominations. We welcome new members to participate in all our activities. Our goal is to lead global development and adoption of innovative practices through the integration of construction work. Nothing synthesizes this view better than the perspective of our members. And as Todd Sutton from DAQRI expressed recently, the Fiatech projects and initiatives associated to mobility have been key sources of information, guidance, and subject matter experts that are leveraging our resources to deliver millions of dollars in benefits. If you're interested in joining, getting involved, would like more information, please drop me a line, young@fiatech.org. Okay, why mobile IT? Well, at the core of Fiatech's interests, we've created this mobile IT community of interest. Mobile technology has clearly enhanced project performance, but we believe it's only just scratched the surface. There are still many opportunities for the industry to increase productivity through improved project information flow. As we mentioned before, in Fiatech we strive to solve practical problems and challenges associated to implementing mobile technologies that are of a practical nature. We as a community hope to realize these potentials, and with your help we can make a real difference to this industry and increase productivity. The objective of the community is to bring together project stakeholders, their ideas, and improve efficiency in the field using mobile IT and share the knowledge to implement those ideas in the industry. Participants in this community will get together in two ways. Firstly, through these monthly meetings, such as this one, where all participants come together to learn about specific applications and technologies. And second, participants get together through subgroup meetings, which focus on specific topics of interest to the community. And during those meetings, participants may carry out work inside their own organizations to advance the knowledge on implementation of mobile systems. The deliverables from the community developed by the subgroups, which would include reports, pilot tests, use cases, will be shared, and it will give an insight to the benefits, challenges and costs involved in the use of these new technologies and applications. Furthermore, the work inside the community can become Fiatech-wide projects through the formal project proposal route. This would increase the scale of a given project and involve all Fiatech membership. The community is a joint effort between Fiatech and COMIT. COMIT is a UK-based organisation whose principal aim is to learn from experience to deliver measurable business benefit in terms of adoption of mobile technology. As such, this partnership supports the work and objectives of the community. Okay, today's agenda. The main presentation, as I've mentioned already, is Marvin Johnson from Bechtel. Marvin will introduce himself. He's got his own bio, 2 or 3 slides in. He's going to talk about the use of augmented reality in civil construction work, and this was a pilot on the Crossrail project. Marvin is an engineering data specialist based in London. After Marvin's presentation, we'll then get into a questions and answers session, and then we'll have some announcements of upcoming events. We have, as I mentioned, some poll questions. I believe there's 4 of them, and there's a couple of videos that are intermingled in the presentation. So I will now hand over to Marvin. Marvin, I'm passing control of the keyboard.
Thank you very much.
All yours.
Okay, thank you. Okay, good afternoon, everyone. Thanks for joining us today. So I'm talking about the augmented reality project on Crossrail, and how we've deployed it, and how we got there really. So just like to go, just check that we can go to the next slide. Okay, right. So what I'd like to talk to you about today is the journey we've gone from using basic AR, basic augmented reality technology. I'm assuming most of you have got a good understanding of, also an introductory understanding of it. I want to talk about not so much about what AR is, it's more to do with what we can actually do with AR technology in the construction and how we've gone from viewing basic AR content to making it useful in the field. So all the way up to our field-driven project planning application, which we put onto Crossrail. So I'll take you through the background leading to that, the tests and the thinking behind the adoption, issues around the content management systems and tracking methods that are being required, and then the Crossrail project itself. Take you through what the brief was, how we applied the tracking and the data workflows that were required, and also all the Sigma findings alongside that to not just take us through how we can deploy AR on site, but how can we gather some real metrics around it. Okay, and I'd like to finish off with AR glasses. When we show this module all the way to Google Glass, I think it's worth noting. Things are happening in the industry right now within construction with these mediums. Okay, just a little bit about myself. I work for the Bechtel Virtual Project Delivery Team. It's to do with its civil-wide BIM role. My focus is on data mapping and innovation within BIM. I'm also the AR subject matter expert, primarily based on the experience I've gathered over the years. More recently for civil, it's been focused on the 4D aspect. So Bentley Navigator Synchro featured heavily, although with other applications within this space. And also, I do have background in AR systems, so commercial systems, off-the-shelf systems, used both in construction and on a commercial side, so dealing with large databases. Okay, so we've got a question for you, so just to gauge the understanding. We've got a poll.
I'll bring it down, Marvin. Let me just drop the first question down so that people can vote. Okay. How far is the construction industry away from implementing augmented reality? Now, please forgive us for asking this question twice. We've got this now and we've got this later. We want to try and gauge if there's any change in opinion from what you see in this presentation. So let me just open the poll. And okay, please vote now. Thank you. As soon as this is done, Marvin, I'll hand it back to you to the next question, to the presentation, through to the next question. That's interesting. Okay, a few more seconds and we'll close this out and publish. A couple more votes there coming in. Okay, nearly 90% voted. Thank you. Close that and we'll share that. So 22% of you say 6 to 12 months, 34% 12 to 24, and 44% even longer. Okay, just make a quick note of that. 22, 34, 44. Okay, close that one. Hand it back to Marvin.
There's a second question then. Sorry, should have been a second question.
Okay. Yeah, there we are. Question 2. Let's open that one up. Is your organization considering the use of AR technology, yes or no? Launch that one. Okay, thank you for answering that one. We've got we'll just share that. 78% considering, 22% not considering. Okay, thank you. Back to you, Marvin.
Thank you. Okay, we've got well, interesting results there, certainly the latter one. So, AR construction, just to give you a taste of what we're a bit of a more of a sense of what we're going to be showing you today. Just play this little, sorry. Video should play. So apologies, I'm having problems playing. There we go. Okay, so just a very brief taster of the field-driven project planning tool we use at Custom House. So get hopefully at the end of today, hoping to change some of your minds with those questions. But this is just a taste of what we were doing on Crossrail, which I'll be explaining in more detail. But as you can see, it's happening, I should say. Okay, so let me just go to the next slide. Okay, so back in 2011, 2012, we published an article on the concept of using augmented reality in a journal of building information, where we talked about the techniques that would probably be required, the formats in terms of BIM, how we'd be able to map those to an AR system, the RL programming language, which currently seems to be, well, apparently is the only AR format or industry standard format around at the moment in terms of graphics and data. And also we talked about the idea of 4D simulations, so moving away from just basic 3D visualization to something useful on a construction site or to the construction project. Okay, so that article can be found in the archives. So in there we talked about some of our use cases that we're looking at this morning. So Revenue Station, which is now part of the Crossrail project in the UK, we started off with the technology looking at laptops with webcam-based systems, and what that introduced us to was the idea of using markers, and you may or may not be able to make out a marker directed on the actual buffer stop. Obviously this line was closed out at the time, but we introduced the concept of we recognise a location and overlay content. This particular system was from Tyre, and we found we could do two things with it. So again, it was a learning curve, but we found we could actually produce live footage, so you can see the live CAD models over the but we could also retrofit data over these video feeds. So the software would allow you to capture video feeds and replay what-if scenarios, very similar to the Synthesize system that's been around for a few years. That was one of the first use cases, and that was just with basic 3D visualization. Okay, and then we had, on the same project, we had a transfer deck being erected, and this is the first stage of the build. You can see a big old marker on the platform there, and again, using the laptop and webcam, we started looking at the 4D simulation side. So the AR software, over 2 years ago, we were able to play through a simulation where we could actually overlay, so introduce VRML models for each phase of the equipment build, and actually through a sequence of XML programming, you could pass the new stages, play through those subsequent stages live in the camera view. So what I can't show you here is what we captured on the day, which you could actually see the transfer deck moving to the first stage and the second stage sequence, all in live camera view. So that gave us an idea as to what would be required to data formats we would need to look at. So VRML was used in those early days, and also the idea of how do we take a 4D simulation, typical Synchrate Navigator world as it was then, into the AR field. So there's a good insights there. Okay, and then also the benefit of looking at more projects further abroad, so not just rail. So PANDA, Temple, Texas, power station. We looked at the same technology, so you can just about make out a marker in the background there. We looked at what else we could bring through in terms of CAD data. So we were dealing with smart plant information. We managed to showcase some free rebar. This rebar wasn't obviously to be put in place as you see it there. This is just purely a test on the outside of the technology. But I think the important thing here was the fact that we could actually use markers and recognise them quite a fair distance away and still play through the or load up the models. On the same site, we were introduced to not only visualising 3D and having the 4D aspect, but also the ability to use clipping planes, so to do live cross sections in the field. So very powerful at the time. Again, it's still using an iPad, sorry, using a laptop with a webcam attached to it, but what that did afford us was the ability to get quite accurate readings by virtue of the fact it was a PC software-based solution from a Tyre. But while we were there, we started looking at, it was about the same time the software changed, where we started looking at the use of iPads with the same technology. So we were sort of growing with the company in terms of what was possible and what was going to be, what was worth investigating further. Okay, so during that time we looked at, and I think this is quite interesting, the various tracking technologies. So maybe most of you are aware of some of the basic understanding, but a lot of people would certainly be aware of GPS-based AR systems. So the ability to load up information from a database and use on device sensors. Now we're fully into the iPad world and iPhone world, and being able to use those device sensors to determine your position and then make a call to a server and download content. So what we can just about make out there is We had various icons linked through from a hazard database which had GPS coordinates or longitude latitude coordinates. We were able to map that and test that in the field. Now this is where these tracking types started to give us an insight into how accurate the systems will be for us. So for GPS, we typically get about 10 metre accuracy, although only on one occasion we achieved 5 metres. But it was quite apparent that GPS would only be suitable to certain types of AI. Okay, so the LOA was longitude, latitude and altitude marker type. Very similar to, in fact it's identical to GPS, bar the fact that it's just from a stationary point. So when we started looking at safety, this type of positioning used like a forced GPS position. You would call it up from a document or a drawing or a marker in the field, and it would assume you're standing in and around that area, that location within about 2 or 3 meters, and it would overlay the model based on your location. Actually, the clip that's highlighted on the Apple website is the technology we used on Gatwick Airport. Marker-based, the next one down. That's more familiar to the generic, to the typical AR systems now made available, whereas a picture or a marker plate of some kind would be used to position and provide positional information. This was mentioned to us because this is what's typically used in the automotive industry, particularly with the tyres. A lot of their background is on this technology was based or proved in the automotive industry, so we knew there was a place for that, but how we progressed to that, and I'll come to that soon. 3D maps, so this is where the devices would create a point cloud. Initially, we were talking about point clouds which we'd have to pre-configure, so it would amount to going out with an iPad, tracking a scene and collecting these points. Within a year, those points went from 100 to 50,000, and they're still going. But they've also gone from having to prepare this initially to having this coupled with the marker system, something called extended tracking, which I'll talk about later, which basically created 50,000 points on the fly based on the known position. So it started getting a bit more interesting in terms of how the tracking could be used practically on a site such as ours. Then we sort of moved into the realms of gravity-aware points, so each individual point that was collected could understand itself in relation to gravity. So again, the device, making use of the device sensors, any information could be overlaid, and positioning would also take into account the gravity sensors of the device. So what that meant was you would have, instead of flickering models, you typically see with GPS-based systems, the CAD overlay would be locked down to gravity, which, as you can imagine, will give you a much more robust and sort of stable model. And something fairly new, edge-based. I think this is something that's personally opened up the field to a lot of companies such as ours, whereby the CAD models themselves can be used for positioning. So the example you've got there is the background is a wireframe model that's been used to be searched for from the software. The software searches for those edges, visible edges, based on the CAD model that was supplied, matches it with the live scene, and then overlays its content. And it's something we see as being quite extending the use of AR further, I believe. So that's just how we've come through this. So we've been looking at all those, come up with our own tracking decision matrix, whereby we've looked at these past projects and tests we've done, and we've basically looked at, okay, well, while these are all great technologies in own right, how useful are they going to be to us? How applicable could they be to kind of use cases where we want to come up with? And so we've looked at the accuracy, the freedom of movement for the end user, the total configuration, survey requirements, because there's a big element of that which we'll see later on the slides. The end user interface, how user, we can't have these CAD systems on an iPad. They've got to be fairly simple to use. Distance and indoor and outdoor use. So we've come up with, there's a few other things on there as well, but essentially what we believe we've got is what would it take for us to look at using a particular type of tracking technology. And based on that decision matrix, we've pretty much focused on the extended mapping with gravity aware and marker-based solution. So we've ended up with a hybrid solution which we've started to use on projects. So we've used that for everything now. We sort of refer to this as to what's our starting point. So I'll come back to that again. Okay, so we've got a tracking identified and defined. A big focus over the last couple of years has been on now. There are many AR systems that are out there. Some of them do have content management systems behind them. But we found that the kind of data formats we're dealing with, these commercial systems, off-the-shelf systems, don't really lend themselves to taking on board the kind of data we deal with, the kind of functionality we need. So, although they've given us a view to how we can use the tracking technology, we've had to look at how we can come up with our own content management system. So central to these formats, we've come up with the concept of, well, it was originally the concept of an AR server, but obviously dealing with all these formats, quickly found what we're actually building here was a BIM server. So once we identified that we could hold this information in a server of this kind, it meant that we could start looking at, the kind of AR use cases we've been identifying over the last couple of years, and feed those systems into a BIM server, or AR BIM server, and start leveraging that server to populate our and it's at this point which, through working with COMIT and Crossrail, that we found ourselves a home to test the project on Crossrail. So the field-driven project planning project for AR would give us the ability to verify the buildability of the design, look at the 3D and 4D construction schedule linked design model, it would involve the 4D planners, field engineers, surveyors and technical, and it would allow us to provide updates for any information captured in the field based on those BIM components, and thus allowing us to be able to collect richer data from the field. Okay. So that was the brief. That was an overview of the brief. The actual team, quite important here. Rather than it just be technical experts, we thought, okay, well, we know what it takes technically to funnel this information through to AR. We really need to not only have a site that's able to test it, but we really want to start finding out what kind of metrics can we gather from the system. How can we test this? So a Six Sigma team was involved throughout the project on all the sites, and so alongside us, quantifying the results, the effects to the end user, within how it affected existing processes, how it improved in processes, and really just a record of how we were performing with this project. Yeah, so bad connection here, so I'm not seeing what I'm clicking at. So Stuart, I think that's your side. So the deliverables.
Oh,
okay.
hang on.
So the actual project.
Sorry, yeah, deliverables. There you go.
Thank you. The deliverables is actually a closeout report totaling over 60 pages, which was compiled alongside of our Six Sigma team. to the project, we had to provide this cost-benefit analysis, and so look at the impact and all the players, and also look at where we could actually roll it out, because what people were finding, and what we were finding during the course of the project, was actually this is ticking a few more boxes than the projects we wanted to test it on, and you'll see that by virtue of the next diagram actually. Okay, so a bit of a lag here, so apologies, jumped ahead. Okay, so the solution we arrived at. Okay, took into, so the typical route you would have your schedule 3D model running through to your 4D model. This information we would take and introduced the idea of taking this into a database, an external database, where we collate that information, configure it for the RL format, so the AR format, serve that to an iPad, but also take in, so you see other construction data sources at the same time. Because it's essentially a BIM server, we're able to link into external data sources. So in this case, we allowed us to be able to take in delivery information, which I'll get to again further down the slides. But the system came very, very flexible from an early stage by virtue of the fact that we were using the server was all this for storing the objects and data. The solution itself, field-driven project planning, was enable us to, once we'd seen that information in the iPad view on site, we're able to call up information for each object, record information against that, add information, and feed it back through the same process. So we ended up being able to round trip the information. So we've gone from the iPad back into the construction data server, back into the 4D model, and feed the information back into the 3D model. And it was about this point here where the project was finding, well, actually that's ticking a few more boxes further down the line in terms of producing as-built models. So we'll get to that next stage. She's a bit too responsive. Okay, so quickly to an example of the tracking system. So this is the indoor tracking system. Okay, so we've started off a marker, but this system using the marker extended tracking with 3D point maps. With each of those point maps, be its gravity, its relation from the device sensor, and you can see that actually the tracking is quite robust compared to what we were quite surprised actually at this early stage test. We knew it was possible, but what we're finding here is that those indoor environments are providing perfect environments for the tracking to work. So you see we've got quite far away, and the objects and these two test objects are still appearing as quite robustly, I think. And this was just a test to see what would happen if you lost the tracking or lost the image. So the marker's completely out of view now, but it takes a few seconds for the systems to understand. So well, actually, I still remember where I am because I've been creating this on-the-fly point cloud. So it's quite a good test for us, really. So just jump through to it. Okay, and this was the outdoors, so the same technology used, and slightly different results, but worth remembering. Now, the system's doing the same thing. It's recognising a marker. As it moves away from the marker, it's building up a 3D point cloud, which is gravity aware. So at a point where the marker, which is probably about that, just at that point there, becomes is out of view, the existing environment provides the tracking. Now it does drop out, as you see there. So we had to. This is at this point when we started refining our decision matrix, and we were finding things like outdoor lighting was playing heavily on the feedback or the actual visual feedback to the system, and things like shadows as well would actually play a part in the software saying, okay, I can see a definite edge there, therefore I'm going to constantly look for that edge. So you can imagine if your shadow starts moving, it can start throwing out tracking. But you've seen the two extremes there of the tracking technology we used in particular on this site. So we're pretty happy to go with extended tracking. Again, the marker's not visible there. We thought, okay, we can progress with this. Okay, so we're moving quite far back and we're still viewing that. So it's pretty good. Okay, so the survey preparation. We had to make sure that whatever we did, because you're having to align your content to the live environment, and because we're using this marker-based system, that ensure that the positioning of those markers within the app and within the live view could relate to something in terms of the surveyors and the content managers being able to align these sources together. So we took the concept of surveyors doing what they do best, positioning markers using reflectors. We thought, okay, we can harness that existing process. We could actually, and into our AR system, we could actually take those coordinates that they would typically record, as if we were putting down any other marker for any other particular use, retrieve those coordinates and use those coordinates to align our model to. So it became quite a seamless process for the survey guys. So from there we would take those coordinates, put it into our system, which we developed in-house, and it would align parts of the model to its nearest marker. And so that when you'll see later on when the software picks up a position and it's got a reference position, it then says, I know which part of the model to start overlaying at this particular point. So I'll show you more of that in action just later. Okay, so the tracking configuration file. There's many ways of using their software, but what we've done is we've taken their existing marker plates and very simple QR code tools, but these markers are actually used in the automotive industry, and they're optimized for distance and camera recognition. So we will take those and use as a base for our extended tracking and gravity-aware extended tracking. So there's lots of information on Tyler's own website. We'll show you how to do that. But essentially, the surveyor will take this part upon himself to create that tracking mechanism to be able to place on the location on site. Okay, so just jump ahead. Okay, so the actual application itself. So again, this was built ourselves in-house. We made it very functional. It's not a very pretty looking application. So we started looking at the functionality right from the first instance. Apart from the initial graphic, the rest of it is quite simple. All you see there is it'll flip through. So we're at the start of the app. We've got security sign-on, which happens to be Bechtel, but it could be anything, and a simple filtering system so that the user can identify a marker on site. He's in a particular location, he places a marker down, he's been able to filter to a location, and then using the AR software, be able to pull up the appropriate model for that location. So that was the idea. We wanted to keep it very, very simple. Features, you'll see, there's a few more features in it, which you'll see in the next video. But the point was we couldn't clutter the screen. It's quite small real estate. Guys typically got bigger fingers than I've got on site, and they're going to be wearing gloves, so it had to be very, very simple to use. We feel we have, certainly from the feedback, we think we achieved that with the basic. Okay, so this is the application in action. Okay, so we've managed to let's get this going. Okay, so we've managed to capture this information by mirroring what was on the iPad back to a local PC. This is live footage. So we've gone straight in, viewed the marker, and started tracking the existing environment. So we've already filtered down into our particular zone in this case. So tracking is quite good actually. We're able to, through the app, we're able to capture. I'll just pause it there. Sorry. We're able to capture objects. Just load that through again. Once we've captured an object, we're problem with that. We'll be able to interrogate that object for information based on the schedule information that's come from the Synchro program, the delivery schedule information given to us from the contractor, and we're able to update information back to that particular object. So for the purpose of the project, we're actually adding in the actual dates that those items have been installed. That information will be filtered back to the database and ready for processing further down the line, which you'll see later. Okay, so this is, and I'll show you some of that information. I'll just show you some of the information we captured. So here we've got the platform beams and platform decking being viewed. You probably just made there's a marker on one of the capping stones there. Okay, we're actually again we're still able to move away from that. Now the alignment issue, although we had, so you can see from those some examples, you don't get perfect alignment all the time. So we sort of counteracted that with the fact that okay, as long as we're quite robust in terms of the survey requires the guy knows he's in a particular location, he knows to load, he's in a particular grid area, he loads it up through the interface, he's pretty sure that these three beams he's looking at are those three beams, because even though they're perfectly aligned now, initially we thought this would be a problem, the lighting effect and the fact which could have been improved if it was darker, incidentally. The end users were saying, well, actually we don't care about that, as long as I'm happy, I know if I've clicked, the information is telling me I've clicked on grid zone 28, I'm looking at the platform beams, and I've got additional information from the design model that's telling me, explaining to me what I'm looking at. All I care about is I've got a visual representation of what I'm looking at, which I can therefore record that information. So we found that's quite a bonus. And there's just another example, early stage. This one last, although it was one of the first view we had. Tracking here, slightly actually clearer day actually. Tracking works quite well for a distance of over 20-30 meters. We're able to walk up and down this section here, and the tracking was very robust, probably due to the fact that we had a lot of fencing on the left-hand side here. But the actual model itself, we started off with sort of shaded models, and the feedback, which was similar to what we had on the previous projects, was really we're not too bothered about photorealistic models. We want to be able to visually see what we just got a visual clue. So we've gone from something fully shaded to something that ended up quite transparent in nature. And because we weren't pulling up so much content, you know, it wasn't such a jumbled view. So that's worth pointing out there. Right, okay, so at the other end of the station, so this is custom house station again, another screen capture. Some of these elements, again, not perfectly aligned, but again through the grid system and positioning system we used, the guys are saying, well, you know, I know I'm looking, I can see that that column there is actually that column is within that grid line. The information I call up on that is telling me it's column number 10A, I think that was. I'm happy, I just want to log information against that. So my point is the technology can be perfect in some situations, outdoor situations, not always 100% perfect, but if it's fit, the application itself is fit for purpose, then that's acceptable. Okay, so once that information has been captured in the database, so we've got a web form that captures that information for the object, what we're able to do is feed that information back through existing control systems. So you for Synchro and MicroStation using bilateral transformer, we're able to, oh sorry, I beg your pardon, plan versus actual. So there's a screenshot of what was expected to be built, and a couple of days later the item being built. So again, visual recognition, the end user was calling out and saying, yeah, I can see that beam's installed. Very clear, I don't care about the alignment. Okay. Right. This next slide is where I thought I was. So the idea of capturing progressive as-built information and feeding it back to as-built teams, but more importantly for that project was back to the Synchro team. We're able to round trip that data into the Synchro model and into the CAD model. Now this is using automated procedures. Now, I'm not sure if you can make that information out, but those actual dates and comments that were captured, so in these red triangles here, captured once in a database, in the I model and creating the synchro model file, we're able to read our database and add all that component information we've just captured in the field at object level, and that will be tagged against the model, both in the I model world and synchro model, using the same data source. So we quickly showed some value there in terms of being able to capture that information and feed it back through a process, an automated process, and reduce that cycle time massively compared to what would usually be done typically on projects, where if you take as-built, for example, that would typically be done at the end of a project, a pile of red lines, so a CAD technician having to add all that information into the model. This system was automating it, and not only that, we were able to pull that into the 4D model and allow the synchro modelers to actually interrogate those dates and start looking at baseline versus the actuals, and start sort of more quickly and reduce the time frame again, start planning the future works based on actual information and not just planned information. So that's one of the biggest benefits that the system found. Okay, so project findings. So in terms of productivity gains through that, all those processes, all the way through from the site engineer capturing the information, the survey team setting information, the 4D modelers reusing that information, and the as-built team to a certain extent, although we've not explored it half fully, well, there was an increase in technical support involved, which is to be accepted with a new technology like this, until it filters through to these existing processes. We found that the productivity gains across the board for that project, over that custom house, were quite significant. There's a Six Sigma report that goes into much more detail on this, but you can see from that productivity gains straight away are starting to justify the effort. And just another slide on the Six Sigma size, realised and potential benefits. It's going to know what equality is like, but the green dots represent the realised benefits during the course of the project. And we were sort of at the beginning, we were finding that actually it's touching upon other existing processes, not necessarily just technical and graphical, but in terms of being able to produce better metrics. We could look at these cost-based schedule linked reports, and probably at the beginnings of something that could actually lend itself towards owners and operators and maintenance of assets, because we're collecting that data and it's been stored, and you've got a historical record of what's happened to that object, because you could actually revisit items in the field, record new comments against them. So there's a lot of benefits in terms of the productivity gains we gained for the projects, but we've also found, or Six Sigma found, actually it could be solving a few, or reducing or solving a few other problems, and that chart there, which when you get the slides, you can look at it in more detail. In terms of actual benefits, just go back. Now, there's while we've used it for field-driven project planning, as we're calling it, there's a lot of the Six Sigma reports from the projects were saying, well, okay, well, there's aspects of this we can see being useful. So certainly for simple things like visualization, which I know some companies out there have already started looking at station builds and content and safety orders and such. I think that's one area which I think will grow quite quickly within the industry. Certainly in the last year, in fact, technology improved massively. So that's one of the use cases that was identified by Six Sigma, in particular for Whitechapel and their stakeholder assurance. We'll look into that going forward. And another one was, by virtue of the fact we were tagging information onto objects, or we worked out using our system, we could actually virtually tag information for asset information out on site. Good key point here is making sure it's non-safety critical items, but there's a lot of marker plates going up, identification plates going up on site, and typically you sort of one part that the architectural side of things would not want to witness, but again, not for safety, for non-safety critical items, virtual tagging and items, allowing people to tag information, like when the owner-operators come into an area, whichever tracking technology you're using, being able to recall, okay, where's the MEP ducting connecting rooms A to B, whatever, any kind of asset information that could be recorded and viewed, and that's another big use case actually that's been identified on the Crossrail site. So sort of closely getting to the end here. Just want to mention the VUZIX at iWeb. We've had the benefit of looking at Google Glass, Epson VUZIX glasses, and there's as you know, there's a lot out there. The DAQRI smart helmets as well, which are shown. I think the point here is that beyond our industry, companies are starting to really look at how they can utilise this information. So there's different types of AR. There's the visual graphical based, and there's the information based, and there's a lot happening in the field as we speak. And also, you may have heard recently about the smart helmet, the DAQRI smart helmet. You're going to be able to view content, call up that kind of information. It's the beginnings, maybe, I don't know, maybe it's the answer, but the mere fact that glass, we've gone from Google Glass on the top of your head to safety helmets, construction helmets, with safety visors, with this technology embedded in it, I think it's a sign of things to come. So early stages, I think, personally, but this is being done right now. So, okay, so probably that's the end of the presentation. Just want to call up those questions again, if I may. Stuart?
Yeah, just bear with me a second. Okay, so asking the question again, how far is the construction industry away from implementing augmented reality? Can everybody vote on that again, please? Couple more seconds. Okay, thank you for that. Yeah, not in the last few seconds it changed a little bit, but interesting. There is a bit of a change, so maybe it was a bit enlightening. Okay, thank you for that. Yeah, absolutely, absolutely. Okay. Okay, so I'll hand that back. Marvin, carry on.
Yeah,
thanks very much for everything.
Repeat the second question again as well, just to gauge with people's response in terms of are they considering it again. Stuart, I think
okay, yeah, okay, beg your pardon. Next question coming in. Okay, can we, right, again, is your organisation considering, oh, it's not put it up on the screen, has it yet? Just a second. We've had a freeze. There we are. Yeah. Is your organisation considering the use of AR technology? If you can answer that one again. Thank you. Okay, brilliant. Thank you for that. I'll just share the results of that one.
I don't remember the results for the first one, but I think there's a change there.
There is a change. There is a change indeed. Yes. Thank you. Okay. Right. Well, we're through to the end. We'll just now take some questions. We've got a few minutes left. Let me just load the questions on. Okay, first question I've got here is which parts in industry are currently using AR? Marvin? Are you able to answer that?
Which,
which parts of industry?
sorry,
Which parts of industry are currently using AR to the best of your knowledge?
Well, to the best of my knowledge, that in talking to a lot of these companies that I've done over the years, I wouldn't be able to name names, but I think one thing's for sure: industrial are using this. Certainly, oil and gas have been using it for a while now. So I couldn't mention those, but it's something that's changed dramatically in the last, certainly in the few years I've been looking at the technology. There's more and more research out there and sort of word out there that's it's going beyond research now. I think people are actively looking at it.
Yeah, well, that ties into the statement that Francesca May has made here. Augmented reality is already being used extensively in civil construction in the US via automated machine guidance. There is evidence of that in Europe as well. I couldn't lead you to any particular examples, but I've seen and witnessed one or two specific locations. And yeah, okay. Next question I've got here. The problem is majority of current AR solutions are not scalable. An organization considers using AR when it could be scaled to current workflows such as field reporting, facility management, etc. That's from Manny Golpavar-Fard. Thanks, Manny. Marvin, could you
totally agree.
Anything about that one?
Yeah, totally agree. Which is why for ourselves, when we started looking at it, you know, and I'm aware of Manny's work as well. Actually, which was inspiring at the time. We in developing a solution, that was our biggest problem. The tracking technology works. You know, the CAD data's there. We knew how to map it. The issue was how do you scale it, which is why we've developed our own in-house system to be able to look at that issue. But yeah, it's if you put it on a graph in terms of where tracking technology was. So say we only had GPS just a couple of years ago, and now we've got all these additional. I think that's going to change over the course of the next 5 years. So it's you know, whether it's an in-house developed system or it's part of someone's research, I think sooner or later it's going to end up in the mainstream as something. Someone's going to address that problem, I think, is the answer.
Brilliant. Okay, I've got another question here from Manny as well. Is your AR solution interactive? Can a user query or push information into the underlying database?
That's yeah, that's exactly what we're doing. Yeah, I think so that database, so the solution diagram we showed earlier on, that's exactly what's happening. We're calling information from a database. So when you look at the objects, what you're actually seeing is just a dumb object, but it's not until you interact with that object do you call up information from the database. Equally, the information we're pushing back that's used in Synchro and MicroStation, that information is coming from the database. So the interaction you've got on the iPad is providing that data back to the database. So the answer is yes there.
Sure. Apologies, we've got a few more questions here. We're slightly overrun. If everybody's okay, I'll continue. Okay, I've got the next question I've got is from Ryan at CCC. Which of these tracking systems will work best indoor where GPS signals are not present?
I think, well, so we've developed our own decision matrix. I think there's a learning curve there in terms of understanding your environment. Every environment's going to be different, whether it's a room full of MEP, whether it's a room just of concrete, exposed concrete. There's no easy answer to that, other than I would say that a hybrid system is possibly the answer. And I think, you know, when you go back to some of those other industries that are using it, so for myself, I would look to the automotive industry. You know, how are they getting around the issues? And I think because every environment's going to be different, one thing is a common theme. You end up with a hybrid solution. So you make the best of multiple tracking technologies, which does give the added headache, if you like, of how do you manage all those different tracking systems, incorporate it into a solution. But I think that's something only your own industries can sort of look and say, okay, what are our typical solutions, typical environments where we want to use this. What you might find, having trialled it on a few sites, is that, okay, well, the tracking systems, if you come up with your own decision matrix for particular situations, you might end up with a completely different, I almost guarantee you'd end up with a different decision matrix to the one we've got based on our work. So yeah, difficult to answer that. I think it's still early stages of all this. Although we've gone past the tracking, what is AR to AR is possible to AR is possible in the field. I think you've got to dive in there, I think, to see what would suit best.
Okay, well, thank you for that, Marvin. We've got a few more questions arrived. Okay, next one. Can you please elaborate more on how the user pushes as-built information into the underlying 4D model? That's from Manny again.
Yes, pushes 4D model. Sorry, can you just repeat that?
Yeah, sorry. Can you please elaborate more on how the user pushes as-built information into the underlying 4D model?
Yeah, so at the point where the users capture that information in a web form, they're sending it back to our database. It's our database that then is read by, we have some middleware which we developed in-house and systems we developed in-house that actually take that information automatically from the database and push that into the AI model formats, and then from my model and then into Synchro. There's a couple of ways we can do that. We can configure it how we like. But essentially, we're using a database and querying the database for that extra information tagged against that object, and then pushing that back to that graphical object, which is then consumed by MicroStation and Synchro. So it's an area which obviously I can't divulge too much as to. It's a proprietary system we've got there, but essentially that's what we're doing. We're taking data, identifying it by some kind of unique ID, and filtering it back to its source data.
Great.
Which is native format.
Okay, thank you, Marvin, for that one. Now, the next question I can answer, this is from Jim Purvis. Hi, Jim. Total number of voters. We had 89 people voted on that one. In fact, in total, I believe it was 89. Next question I've got is from Brian Hoover. Were you using Wi-Fi or cellular data for your network connection?
We were, on the sites we were looking at, the answer is yes to all of them. Typical sites don't always have the coverage you want when you're trialing this kind of technology. So we had to use both Wi-Fi, 4G, and in some cases 3G signals. It wasn't in some situations, so as the bulk of the project was outdoors, we were quite lucky in that there was a good 4G signal to fall back onto. But your data connectivity will be an issue, and there are ways around that, of course. But we've already looked at, there are ways around it by looking at sort of disconnected data sets, cached data. And again, it comes down to the management of the data rather than just, you'll never be able to push a whole project into an iPad. So we built our system around just calling up what you need, and if you can control that, you can, number one, get it down a Wi-Fi connection, or down to a 3G connection if you must. But if you do lose connectivity, there are ways to be able to store that data, sort of local data, on a device. We're using our other systems, in fact, connected systems, and be able to sync that information back to the server at a later stage. Okay,
thank you. I've got more questions coming in. Thank you for those. I was wondering if you could talk a bit about how the AR environment has offered a benefit to projects over using a purely virtual reality-based approach to visualization. That's from Stephen Ayer.
Okay, very good question, because I think
the
two are merging. I think what's happening in the VR world and AR world are getting closer than ever. In terms of the data, the way you're preparing the data, making it accessible. So in the VR world, you don't just want to visualize something, you want to be able to call up information. So I'd say those processes are starting to look very, very similar.
Yeah.
To the end user, I think, if you take it as it is now, the current field, I'm not saying this is as far as you can get with that technology, but with VR, if you're talking about headsets or some kind of overlay, information overlay, you're obviously not going to get that on a construction site. Guys aren't going to be allowed to walk around with the headsets such that they look like now on a construction site. And also the issue of being able to, with VR, totally immersing someone in the environment, certainly applicable to training centres, but you possibly don't want that in a construction environment. Whereas AR works the other way around. It's you actually, we've done lots of demos of AR internally, and what you actually want in those cases is a VR solution. So you want the same functionality, but you want a VR solution, certainly for training. Whereas outdoors, with it, I'd say the biggest benefit of AR is that you've got the ability to see through. You're just seeing items of interest, and it's not disturbing your view, because safety is going to be a problem. Or it's supposed to be a problem. You've got to have cognizance of where you are on your site. So I can see VR being used. I see the technology being used in VR coming across to AR personally.
Yeah.
I think they're still slightly different use cases.
Okay, we're going to have to hurry along a bit here. We're 10 minutes over now. Can I just ask no more questions? If there is anything else, then drop me an email, because they seem to be coming through thick and fast. Just drop me an email and we'll do our best to answer any questions you might have afterwards. And that goes for all the presentations that we've done. Next question we've got here. The system does not seem to process occlusion. Sometimes your elements should display behind real-world objects, but they always display on top. Was that an issue in this experiment?
Well, this experiment, we only looked at visualizing information that was within view, so not hidden. But the system is set up to read occlusion models. So for us, what we would do is everything that's recorded as being captured, we would send a signal to the system that would say, well, that object is now occluded. So obviously based on the accuracy, you've perceived accuracy, if you take the indoor tracking example, if those footings that are in a way have been captured in the system, a tag would flag up against it, so that's now an occlusion object, and then the software would know that that's not to be viewed, therefore anything behind it would be partially obscured. So you're right, we didn't see any occlusions. Most of the data we were capturing was visible to the end user, so he wasn't trying to identify anything that was hidden to say yes, that's been captured or that's installed.
Right. Good. Okay. What is the response from site staff, engineers in particular, to the technology, specifically those who are not so technically inclined? That's from Joshua Close.
Yeah. Surprisingly positive. I think when we started off pre-Crossrail, when we were looking at, in fact, when we looked at the Bond Street trials at the same time as Costain, I think it was, it was that point where the end user, we were engaged with the site teams quite a lot, and it was a case of, well, visually we were aiming at too high. They said, well, okay, we don't care about it. So I mentioned that before. They weren't interested in the visual aspect, the photorealism. Once we dumbed it down to, or sort of brought it down, I shouldn't say dumb it down because it's perfect actually. Once we brought it down to basic geometry, just being able to visualize it, they're saying, then when it's changed, people are saying, well, actually now actually it's been useful. And I think the point where AI, and I think this is the most important point, is that, I presume you can still hear me.
Yeah, carry on.
Yeah, sorry. The point where we started being able to filter information back. So in the case of Custom House, when we started putting this tool in the site engineer's hands, said, okay, well, now you're capturing information in the field. The first thing he said was, well, straight away, I'm not having to go back to jot all this down on a piece of paper if I've got one on me, go back to the office, type it all down, phone up someone on the end of the phone or the scheduler and say, right, okay, we've done this week. It's all there, and remember any issues or identify any issues when I go back outside. We made their life simple, and probably another important point was we made their life simple, and we didn't just give them another CAD application to use on site. Nothing to put down CAD applications, but for something simple as recording progress, they were very responsive to the idea, and the I think the most telling thing was they weren't even bothered about the technology. They were happy the technology could do what it was doing. They didn't really want to know about it. They just want to know, how can I reduce my time on site and be more efficient? And I think that's the feedback has almost 100% been absolutely positive.
Okay, thanks for that, Marvin. Couple of quick answers here, and then we need to close up. Which is the single most used function in the host of AR functions covered in the presentation? And that's from Dr. Bargave Dave.
The functions, well, as we've built them all ourselves, I think the biggest function has been the ability to write information back to a database. So essentially what we built is we can actually write anything back. So you could probably see the possibilities also in terms of construction and being able to, anything that can reduce cycle times, which has been the focus of this project. That ability to write things back has been the biggest functionality. In terms of the actual AR technology itself, it's, I've seen this change so much. I think just not having to worry about how the tracking technology works, just knowing that which one to choose is a good thing as well. So it's probably not the perfect answer to that, but I think it's probably worth mentioning that.
Okay, last question. In implementing AR, what have you done regarding these management processes, roles, responsibilities, culture, and the refusal of staff to use it? I suppose a little bit of that in one of the previous questions. So what have you done to reorganise processes, roles and responsibilities to incorporate AR, if anything?
So alongside, as I mentioned, we had the Six Sigma process running, and it was their job to look at those existing processes and involve teams. So regular meetings were held with everyone involved throughout the course of the project, looking at their expectations, their barriers to adopting technology, and once that Six Sigma process was worked through, you quickly arrived at a solution which didn't include the technology people, I might add. We weren't trying to sell them anything. It said, okay, well, we see your barriers, we can see your issues. Through the Six Sigma process of identifying the existing process and how having understood the technology, how we can actually streamline some of those processes, we ended up with a set of procedures. Now, we're still at the stage of, this is a pilot beyond the trials we've done. I think this found out recently that the Crossrail projects team, they are looking at extending the trials. So with no doubt we have to go, not only now we have procedures in place which is Six Sigma endorsed, we need to go through a process of looking at the scale of it. Although data-wise it's scalable, we have to look at the scalability of it in terms of what starts happening with using multiple sites with those existing processes and refine those processes, because they are slightly tweaked processes to existing. But again, the Six Sigma report will show that actually where there were barriers to adoption across all the involved parties, those barriers quickly lowered into something that Crossrail would like to proceed with in the future.
Okay, thank you, Marvin, for the answers there. I'm just going to finish up now with the next slide or two. We've got a conference coming up end of October, 30th, 31st, the latest research and development, technology, work, people, that will enable a path towards digital construction. Early board finishes on October the 20th. More information, have a look at that tiny URL. During these 2 days, we'll have cutting-edge views from industry leaders on how the people, technology and construction can engage in more efficient processes. A set of presentations in this conference present an integrative view of how these elements can be organised for moving into digital projects. So please have a look at that. Announcements, we've got the next mobile IT community on the 19th of November. Please save the date. We do meet every third Wednesday of each month at the same time. And then one after that is the 17th of December. One thing I will say is post this meeting, there's a survey going out. We'd like your feedback, please, to try and make this more interactive, if it's at all possible. So please give us some feedback. I'd like to say thanks to Marvin again, thanks to Fernando's input. And thanks to everybody for attending. Thank you very much for the questions. Social media, we've got a number of links there. The recording of this webinar will be made available within a week, so please watch out for that on YouTube. So thank you very much for everybody joining us, and we hope to see you on the next one. Thank you very much.